Okay, welcome back, everyone. Before we go into the afternoon, I'm just going to take up the challenge that I left you with before lunch. So the last thing we did was to plot a line plot of species number over year. So now we want to plot a different line plot. Let's do this just the second one because the first one is similar. Calculate the mean weight per year for each species individually and plot in a line plot with one facet per species. Does anyone want to say what they did? Okay, so what if we're going to start with group by, for example, what would we want to group on? Human species. And now we want the weights. So how do I get the weights and take the mean? I didn't actually do this yet. Okay, so anybody? How do I get the weight and take the mean? Wait. That mean? Okay, let's see what we get here. Okay, cool. So this looks like the right information. Anything else we should maybe... So how do we get this back into a data frame now? Reset, yep. Okay, let's make this a new data frame. Cool. All right. So now we've got a thing that looks like this. And now we want to plot for each species, or a plot with each species, that mean weight per year. Any ideas? So, okay, we know we want to do facet grid because that's how we did line plots. We know that the data is this data frame. What else? What other parameters do I need?
We had
call equals species.
Call wrap.
All right, cool. So now we need to do the map. So I'm going to assign this to G again. And now the last step to make a plot, g.map. And now we're going to use the matplotlib plt.plot. We'll find out if matplotlib has been loaded. And we'll plot these two variables, year and weight. Isn't. Woo, awesome. Very nice. So you could play with the parameters, you could color by species if you wanted, but this is definitely a good solution to plot this. Does anyone have any questions about this before we move on?
Scroll up a little bit.
Sure. To here?
Yeah.
Yeah, okay. Yeah. Sure, I will copy this onto the Etherpad. Oops. Oh, okay. That is the end for me. And now for the afternoon, we're going to have Sarah. Do you want to introduce yourself and we'll start? Yeah.
I'm Sarah. I'm a PhD student in biomedical engineering. And we will talk about in the afternoon. Just let me delete these. Don't need them, or let's just scroll down. So in the afternoon session, we will talk about tidy data. The first thing is tidy data. What does it mean? What are the different formats, and what each format is used for, and is most valuable for what type of data or analysis. And then we will switch to plotting again and talk about how you can control your plots, how they look like, and also what type of plots are more useful for what type of analysis. And then we end with how different colors and color schemes can be used for your different purposes. So what is this concept of tidy data? So if you look at this table, this is the table that is most, okay, they are telling me that it's a bit too small and I need to zoom in. Okay. Is it good now for the back, people in the back? Perfect. So this table is the table that is most easier to interpret and understand for human beings. We go to the intersections of rows and columns and we find out, okay, this person, the weight was this, the height was that, and each measure and each observation is easily visible for us. But this is not a good data format for languages, for the computers to do analysis on. This is the format that is good for computers because you only have one column of values and each observation takes one row. So you can see that it is repetitive for us and it's confusing for us, but for a computer or for computations, it's easier because every value has all the labels in one row beside it. So when you want, because all of these languages do work with indexing the data frames, it's easier for the program to pick, for example, anything that has person A in it or anything that has weight in it. it picks only the rows and it indexes the rows that has this weight label, and it takes it and it does the computation with it. It's not very easy for the programs to look at the intersections like our eyes follow this table. So this kind of table is what is called a wide format, and this kind of data frame is what is called long format. So you will need to, in your analysis, you will probably need to switch between these two. So now we will learn how to do this, reach to these different formats with our data set. So we will go back to our survey data. So you have your surveys open. So we don't need to go through the, let's just to have a reminder, look at the head of the surveys. Oh, we don't have, surveys. So this is our big data frame. One thing that is good to do now is I want to show you how to change between these two formats. So it's better to have a subset of this data. This is really big. We only need, it's better to choose a smaller subset to be able to see how it changes. So let's do a bit of preparation. I want a few species, 3 species. So let's select a few species. Species sub. Let's say I want to choose albicula. Then flavus. Sorry if I'm pronouncing all wrong, but these are really strange for me. Very yummy. We want these 3 species, a few plot ID sub. Five, 6, 7, 8, 9, 10, and 11. And then a few columns like record ID, species, of course, weight, and plot type. Now I cut this part, these desired parts from my data by using block surveys dot these locations, which are surveys that the plot ID of them, from surveys, the rows that the plot ID is in the plot ID sub that I defined up a few lines before. And I want surveys rows that the species is in the species sub that I defined. And the columns as the calls that I defined. Let's see how it looks. Let's see how much of the data that we got. Oops, sorry.
On line 3.
Yeah. Oops. So this is maybe a bit too small. Let's keep the plot IDs. So let's do the same, everything the same. Or you know what, let's also write it another way. So we want the species. And we want the column subset to be these. And then I defined service sub as the service sub, the service locations that service species is in species sub that I defined, the variable that I defined. And the call sub. I don't have a typo. Let's see how it looks. Service subhead. Okay, this is better. So if you look at this, we have the record ID, the species, the weight, and plot type. It's a smaller version of your service. So from this, we're still on the preparation. From this, imagine you want to find the relationship between the mean body weights of each species with different plot types. So one thing you do, you can do the mean weight. Let's also do that. So these are, again, we're still preparing something that I will show you how it comes to use now. So imagine you want the, as I said, the mean weights per plot type. So you do the service sub. Sorry. Higher? Yeah, sure. Yeah, sure. Good? Bigger? Sure.
Could you please scroll up real quick?
Yeah, I will. Let's just first. Okay. How is now? Good? Maybe even a bit more. Okay, it doesn't go more. So we are subsetting. We are choosing a subset of our service because service was too big, and then you couldn't see the change between the wide and long. We haven't done anything about wide and long formats yet. We're just subsetting your data for now. I want to choose a subset of service data to work with it. So these are just choosing these rows that have the species, these three species, and these columns. So if you look at the data, you have these columns, and you only, from those species that you have, you only will find 3 of the species in these 3 columns. So you took a few desired rows and columns from your data. You extracted this from service. Now you have a smaller service subset that you can now work with, because I'll show you that you will only have 14 rows that then you will see the changes between long and long and wide easily. Now, what you want to do here is you want to mean body weight of your different species in different plot types. So what you do here is, this is sort of a continuation of the work in the morning. So what we do here is let's do this here. We do service sub, group by. We want to group it by, what do we want? We wanted the weights of the species. Based on plot type. So we group it by these two, and we want the weights. So on this, we want to apply the mean, and we use the reset index to have it as a data frame. Now, if you plot this, if you show this, if you print this, this is just the name we chose, GSP. Oops. I haven't, yeah. Yeah, sorry. What bracket is missing?
Sorry,
Ah, yes. Perfect. So now, this is the mean weight of each species on plot type, each species on plot type. So you have this. If you look at now we come to the concept of wide and long. This is a tidy format. This is a long format. You can see that every you have a column for your values, your measures, and each of them have repeated. You can see that this control, long-term exposure, rodent exposure, blah blah, and then again control, rodent exposure, blah blah for each genus. So you have repeated labels, but you have one column of values. So you have one observation for each row, and it's tidy. That's why they call it tidy. Because for the program, this is the tidy version. Now, let's make it in a way that we can see it easily. This is not very nice for us. Let's make it nice for humans. Let's make it in a wide format. The way to make this in wide format is with the function called pivot. And this pivot, let's do this. GSP.pivot. You need to define what you want to be the rows and what you want to be the columns and what you want the values to be. So you need to say index. Let me put it higher. Okay. Index is plot type. Columns is a species. And my values is weight. This down. Okay. Typo again. Ah, sorry. Wait. Now this is useful for us. Now this is meaningful for humans. So we have it in a table format, all these, and the all the plot types on the in rows, and all the species in columns. This is so useful, and this is so frequently used that in pandas you have a function called yes. Yeah. Scroll up to see the.
No, sorry, just what you just did. Yeah. There, yeah, just did that.
Maybe you can go full screen.
Yeah, I couldn't. It didn't work. Okay, it worked now. Huh? Where? Perfect. Thank you. Okay. So with this pivot, we turned our long format or our tidy data to wide format. As I said, this is used so frequently that Pandas has another function that does the mean for you as well in it. I will show you in a second. So we could do in this. We didn't need to make this GSP, this service sub GSP. We didn't need to do this mean ourselves. We could do it with both the format change and the mean or any type of aggregation with one function that is called pivot table. So I will call this PVT sub PVT, and I'll choose service sub. So see, I'm not doing the function. I'm not applying the function to the GSP that I created, but to the original data service sub pivot table. And again, it's the same thing. You need to define the index, which will be the rows, columns, which will be the species. Values in rate. That's it. And if you it. So here you get the same thing that we got from first doing the mean ourselves and then just using the pivot function. We can get the same exact table by doing pivot table on the service sub. So it does the mean for us. I will show in a few seconds that you can change that mean, the aggregation function, to anything. It could be the median. It could be other things that I'll show in a second.
So the mean is basically like the standard aggregation mode.
Yeah, always. If you want to change it to another thing, you have to define it, and I'll show you in a second how. So this type of, that again, it's not only for a presentation for humans, but this type of format is also, for example, very useful for making correlations. So for this service sub PVT, from this, applying the correlation to this table is easier than to the tidy format. Here, with just .core, you get the correlation. Another thing is also because you defined your indexes. You could define. You could change your rows and columns. You may find it. Oh, sorry. You may. Control C. I just want to copy paste and not repeat typing. You could change the index and columns. So you wanted to transpose it, or use, what I mean. You wanted this species to be on the rows. You only needed to do this, changing the plot type and species. So you want the species to be the index. You get the species to be the index. It's just changing the. Now you have this transposed table. As I said, you can have Let's have the original one. You can change the function, the aggregation function. You can have the sum of all the rows and columns. For that, you get the margins to be true. And for getting another aggregation function, it's just agg func. And I want it to be median. It's not, I don't put it into another variable because I don't need it. I just need to show it. So now you have these all, the two alls are the sum of the rows and columns, and the values are now changed to median. Any questions so far?
The margins is what again?
Well, let's keep both.
The last column?
The last column, the all. So this all is the aggregation of the of the columns and rows. Everything clear so far? Put up blue stickies if everything is fine.
What do I find like a list of all the aggregation functions? How do I find like a list of all aggregation functions?
In the documentation. Let's bring up the inspector, for example. If you bring up the inspector, did I bring it up?
It's on your right, straight blank, because you have nothing selected.
You're right. How can I go to my thing now? I can't find. What is my?
You have to make the text reappear. What did you press again? Like command.
I have no idea. I don't hear you. Thank you. Yeah, so this is the picture. Let's put it beside us. Let's bring this. I'm completely. Come on. I'm completely lost here. Never mind. This.
When you go out and you
But then how can I bring the inspector without screwing up the rest?
It's fine. You go out of single document mode. Again.
This is in auto.
Yeah. Then hit F5 and remove the commands section.
Yep.
Yeah, now you can find it. You just search it.
But how can I close this now? Never mind.
You just hit commands.
No, I want to close this part. This column.
Press files.
I did it. Okay, never mind. I thought I did. So, thanks. So here when you have the inspector open, if you do the plot this pivot table, it brings all the documentation for you. And you can find what to use there. If not, you can also Google and bring the documentation of all the documentation that is in the inspector is also online. So you can find it here that what aggregation functions does it get. This is too big now. You can find examples. Well, I can't find it here. Let's look it up. Online. Pivot table. Icon. In the documentation is here, and hopefully we can find.
They're actually not listed there, but I added a link in the Etherpad to a section of the panel documentation where most of them are listed. But for all of them, like you kind of need to, if you do pandas, sorry, your data frame dot something, you can scroll through everything and you can find what's the aggregation functions. Or the link in the Etherpad to the most.
Perfect. Let's go to. So yeah, you can use some, of course. So these are the examples of other types. Mean, sum, size, count, standard, deviation, variance. So this is a good list. Thanks. Max, min, anything. Okay. So we have this service sub PBT. If I run the PBT as this, we have this, and we want to perform computations, as I said, that is a higher analysis. It's not just for presentation or functions like correlation, but you want to make it easier for the program, you need to make it to long format or tidy data. Imagine you had this from the beginning, not that we made it right from the long format ourselves. The first thing to do is to make it a data frame with those indexes. So a little thing that you need to do before the transferring between the formats is to reset index. So you do this dot pbt dot reset index. So now your service sub PBT is the same thing, just having these indexes, because then it will be an axis that the program knows to turn around your data, turn your data around it. So this is your wide format. Now the function that changes the wide format to long format is called melt. So you do this service sub PBT dot melt, and you define that the column that you want to stay intact is the plot type, for example. So the ID variables is plot type. This is the simplest way to do it. Now, if you remember, this is the thing that the subset that we took from the beginning. The value is the weight, the species, and the plot type. So we reached our previous data format. That's why I chose a subset, because it's easier to see. And you believe me when I say that with MELT, you only convert your data frame from wide format to long format. So this is the same mean weight of all the species in plot type. You could do this. Yeah, it's just MELT here. You could be more expressive, you could define all the different variables that you want to be there and be the column that changes and the column that doesn't change, or the column that stays and the columns that gets repeated. You can define all of those in different variables. So we want the service sub PBT dot melt. Now we define all the variables, all the parameters. So we want the ID variables to be the plot type. We want the value variables. So these are the parameter names that you will get in the inspector. If you had it open, you would see that these are the things that you can define. These are the parameters that you can define for this function. You know that you want these two species. Let's go down.
Wait, can you scroll up a little bit?
For melt.
Yeah.
I'm repeating the same thing. I'm repeating melt, but with more parameters defined. But this is the simplest. If you just know the column that you want to stay and the other columns to get repeated, is this one. Just defining ID vars, melt works. But you can be more descriptive, more describing more of the parameters, all the parameters.
No, I just found my error.
Oh, okay.
I melted the data with the all.
Yeah, you don't need the margins. So albicula flavus, the variable name. So you saw that when we did it with only the ID variables, the value name was not there. The weight was not up on top of there. So we want to now define it. We know that the variable name is a species, and the value name is weight. So now we will have labels for top of there as well. Plot type. Service. Always. Typo. Okay. So now you get the same exact thing that you got before, but you now know that each of these parameters get what value. So we're melting our long data format to a wide data format. And we're giving it everything that it needs to know. The ID variables, the value variables, so the ones that get repeated, the value names, the value variables, Is everything clear so far? Shall we go to a challenge? Let's go to a challenge. Shall we? Are we all in blue sticker level? No. So we learned basically two functions or three functions. One was pivot, one was pivot table, if we want to also have an aggregation function, but you can also always do the pivot in changing without doing some computations on it. So the two basic ones were pivot and melt. Pivot to wide to long and melt long to wide. Maybe you're getting, if you're getting an error, maybe it's because we changed the service subplot here. I didn't have to name it. Maybe go back to this cell. That service subplot is sub PVT is this one, is this wide one, and then run the melting here. So in this margin here, as I use the PVT as well, I didn't use another name. My bad. Let's go to the challenge. Maybe I can copy paste it. Yes. So make a data frame with year as columns, plot ID as rows, and the values as the number of genera per plot. Remember to use the nUnique function and the reset index functions. Let's have 10 minutes for going through this challenge. And anyone that has questions, I can come. We can come to you while working on this.
And if you feel like you need some help fixing that for that challenge, there's also coffee and tea. You can take some and activate your brain. Get the challenge.
There's new coffee?
There's coffee, decaf coffee, it should be
Fresh. Okay.
like warm to hot.
The genus. Genus. Jesus in and in part. Oh, these two Jews. Okay, for this particular function. Okay. So you go to the Jews column. Okay. And then the unique, you feed it with anything you feed it. Okay. And what I need the value is what data columns. Quantities rows. The values are the number, so every is the number. So present us. Okay. To be able to see. Otherwise, you have to see. Okay. Thank you.
So put up your blue sticky notes if you're ready to move on and solve the challenge. Okay, anyone wants to suggest what to do? I call it genera per plot. What should I do on series? First thing to do on series, anyone? I think at least a few of you had it, so you may want to say what to do here. Do a group by? Right from the beginning, before grouping by. Your series is your raw data. So you first want to group it by the things that you want, which one of them is plot ID, and the other one is year. And you need brackets as well. And you want to take whatever genera there is, or whatever genus there is, from based on these groups. So whatever genus on plot ID and year. This is what you want to get, correct? Let me show you. And you want to tell it how many unique unique Yeah, wait. Well, okay. How many unique, correct? And unique? I wanted to show you something before that, but yeah, how many unique genera you have, and you also want to reset index because you don't care to keep the original indexes because you're taking parts of your data. You don't want to have 1,000 something, 700 something as your index. So when you have that, let's see how it looks first. So now you have plot IDs and years and number of genesis. If you do unique instead of n unique, you will first get a better idea of what is it doing. So for each plot ID, all the years and the two genera that for example, it included. The second row is again the plot ID 1, year 1978. You had 3 genera. So it's repeating for each plot ID, repeating all the years. Again, for 20, for example, for 23, plot ID 23, repeating all the years. So these are the repeating columns, and the genus is the value. So this is, again, a tidy data format. But we wanted number of unique, not the names. So we use n unique. And then now here we use the pivot table or pivot. Here we don't want to do any aggregation on it, so we use pivot. So this will be dot pivot table. So you only now want to change this long format to wide format. You know that your index you want your index to be this plot ID. And you want your columns to be year. So now you have the same long one in a more easier to interpret format.
Can you show the first comment again?
Yeah, I'll keep them, sorry. Dot unique. So you grouped by plot ID and year, and you took the genus column. You counted the number of unique genus per plot ID and year for each row, and you reset the index. Ether bats, sure. Okay. We could do the same exact thing in a more concise way that I'll show you now. So we could do all of them in one row, one go. Let's call this genus year wide. I could choose again service, group by. Let's copy these parts. Same exact thing. But unique. How to set index. And we could do dot pivot table right on there. Combining those two lines in one. And if I don't have any, hopefully, any typos, we should get the same thing. Yeah. It's just making it in all in consecutively. Yeah.
It is differently.
Let's see what. You got the same thing?
Looks like the same thing.
Perfect. What did you do? Tell me.
So I went like straight surveys dot pivot table, and then index block ID, columns year, values genus, and aggregate function and unique.
Nice. I didn't know unique is an aggregate function.
I just tried.
Perfect. Let's do it here as well. So service dot plot dot pivot table.
Surveys dot pivot table. Then index plot ID.
Index plot ID. And
Columns year.
year.
Values.
Oh, sorry, columns. Values.
Genus.
Okay.
And aggregate function.
Great. I found to be and unique.
Unique.
Unique. Unique. And unique like this, or and unique just?
Not just
unique?
like that, yeah.
Let's see. Excellent. even smaller, even faster. Beautiful. Thanks. Yeah. You're too stuck on group by. Okay. Now the second challenge was to revert it to a long format. That's probably you all got. An error per plot, for example, the thing that we made. And making the ID variables to be the plot ID. That's it. Let's see the head. Okay. An error per plot.
Should we have used the wide one? The wide,
Didn't I isn't this the long? This is the wide version. General per plot, isn't it?
okay.
Oh, I changed the name. Yeah. Sorry. Well, but this one is also wide. General per plot.
You reset the index.
Okay, let's use the. Oh yeah. Sorry, we don't have index. What we do? Yeah. So we have plot ID here. That's the thing that I already mentioned. So we should first do the reset index. Reset index. Before melt. Sorry. Yeah. Now we get the same thing back with indexes, of course. So it needs that sort of access to turn your tables around. The program needs this index to know what row is what. So if you see it like this, that plot ID is one of your variables, you have to make an index for it and then do the melt. It's not working. Maybe.
It's okay.
No, we get to it.
They actually have the name. So when a column has a name, you collect the name of the column. It's a bit like that.
And if I do not, what's the argument again?
You have a question?
It's not really what we're doing. So it's cool.
Here.
Okay, so now we switch to plotting. In the morning, it was mentioned a few times that all the seaborne and higher level plotting is being done using matplotlib. So it's very useful to know functions in matplotlib so that you can have more control in the styling of your plots and making changes in your plots. And then you will also understand better the keywords that you used in seaborne. So let's do some manipulations of your plots or styling of your plots in matplotlib. The first thing is to import it, of course. So import matplotlib. Let's go higher. Matplotlib dot plot as plt. Lib, sorry. Then one other thing that is needed to be done is this thing. It's just for matplotlib inline to force it to plot your figures in line in your notebook. Otherwise, it shoots it out. Plots the figure out. So, and for these examples, so far we were more focused on the data and how the data looks like. Here, just to show you the different styling, we only use a very, very simple sort of data to plot. So let's make it ourselves. I choose X as 1, 2, 3, 4, and my Y as 1, 2, 4, 3, something like that. And I want to plot it. So I called matplotlib library as plt. I import it as plt. So whenever I want to call it, I call plt. I want to plot X and Y. I mean Y over X. Now you have this. So this was the code, just plt.plot. The first level of control is made by you putting your plot in an object. So you define fig and x. Again, these are variable names. They could be anything, but it's meaningful to say fig and x to be this plot. And it's good to first make a empty framework for your plotting. So I make a subplot, and I make it empty. When it's empty, it means only one. It gets one as default. So now you have one empty framework that the object is put into fig and x, and you will see how each one is useful. Now, when you want to plot something, you just plot it on x. So you say x plot x and y. You get what is happening? Now imagine you want, and I use copy and paste from now because again it gets repetitive. So now imagine you want to use make the same plot but as a scatter plot. So I changed the plot to a scatter. The same thing, fig x, put the plot subplot into fig and x, and then using the x, plot for me the scatter of this. What? Let me
Shouldn't it, after like the X dot plot, show the instead of scatter when we did with
Plot.
plot?
Okay, I just changed this to plot. Are they all in the same cell? Are they both in the same
Okay.
cell?
So they need to be in the same.
You could even do combine the plots, combine different plot types. So I do the scatter of the same thing, X and Y, with red color. The keywords are also very intuitive. It's good. And ax plot. So on the same axis, plot this for me. So now you can, if you didn't use that ax, if you didn't have that object, you couldn't that easily plot things or plot over and over on each other. So it's very useful to put it in an object and use it however you want. So I want the plot to be, the line style to be dashed. So now I have the dots for a scatter plot and the dashed line for my plot. Now let's change a few more things. So I copy and paste, or I do it on the same thing. If you want, you can. I want the size of my markers in my scatter plot to be 100, to be bigger, and I want the line width to be 3, also bigger. So you can do different stylings. You can look up the matplotlib plot, for example, find out how whatever keywords that there is and whatever styles that you can change, the features about your plot that you can change, and use it. Yeah.
How do you change the line?
Sorry. Sorry. Yeah. A very important thing when you want to display any figure as a scientist is to have labels. Labels are very important because your audience should know what is being plotted, of course. It's not only you that need to see it, even your future self. If you go back and you don't have any idea. So it's good to always have titles and labels. So we set title for our axis. Let's call it line and the scatter plot. And we can also set the X label. The measurement X. Now I have a title and I have an X label. I don't go down so that you have the code. You probably have the figure on your laptops. So it's intuitively, if you want to now set the Y label, it's just the same thing, the same function, changing X to Y. Put up a blue sticky if you got this figure.
Can we change the font sizes as well for the labels?
Yeah. Font sizes for labels. should be font size. Let's make it 15. It's probably too big, but I don't know. Let's try. 50. Oh, it's too big now. 20. The same for X label. You can change the font size. Good, blue stickies. Something else that you can do. You can have different subplots. So you could, it could either be different data set, or you want to separate these two plots, for example. For now, we keep it simple. The same data set, but we want to have two subplots for our plots. So what we do is we define two axes. That's all. When we assign our subplots, and now when it was empty, it was only getting one, but now we want 1 and 2, meaning that I want 1 row and 2 columns. If you want 2 columns and 1 row, it would be 2 and 1. If I do 2 and 1, we'll get this. But it's, for now, it's better to be 1 to 2 to see them more properly. Don't need to scroll down. One thing to add here that is good, that makes, it's just for aesthetics, is to make it tight. Because then this function, tight layout, what it does, it just separates properly your subplots so that your numbers don't, the numbers on the y-axis don't overlay each other. One other thing that you can do is also to change the figure size. It was mentioned in the morning. You want the figure size to be bigger or smaller for this display purposes. We said that in saving you can change things, but now in displaying as well you can change this by, in your subplots, assign the figure size. So fig size equals, I do 8 and 4. You will get what is useful for you, or what works for you, what numbers work for you with just playing with it. Playing with the numbers. It's based on the screen that you have.
Isn't it tight layout again?
To make it automatically the location of your plot, the subplots, to not be for the y labels don't overlay each other. It just places your subplots in a nicer way.
Okay.
It just sets or resets the subplots. Okay, so we have this. Let's add our plots to it. For x1, I want a scatter. X, Y, color red. And for x2, for axis 2, I want a plot. X, Y, line style, dashed. As we said, we always want the titles, so let's copy and paste the titles. Now we have 2 titles to set. So title 1, I want to say it's a scatter plot. Let's not choose the font size for now. And then X1 set table, X2 set table, set title, sorry. Set title to be line. Line plot. Now I will have them both in 2 different plots. I'll go back to code. I don't scroll down, but you get a glimpse of a little bit of the plot too. So these are how you can style your plot and control how your figures look like. Is everyone getting the same? Can you put up the blue stickies, please, if you all have this plot. Thank you. Okay, perfect. Everyone has it? Have it? So let's go to a challenge. Time for a challenge. Let's go to a challenge. This is a nice one. It's a fun one. I'll put up the link to this list of colors. I put it up in the Etherpad. It's very useful. Choose one of these colors. Let's just copy it over. So it's now in the Etherpad. Go to this link. On the Etherpad. And change the color of the same plot. Just change the color. See how it looks. And you already saw it in the morning, the markers, the documentation for markers that you saw, the link. Go there and change the marker as well. Find the marker that you like and change the marker in your plot as well. The same plot that we plotted. And line plot, color, anything you like. And then we plot it here. And we will have a prize for anyone who had the funniest looking plot. I'll put up the code. I'll bring it to the code if you or do you like the challenge to be there? The challenge was just to change the color and marker. I'll put up the code on the screen. We'll be back in 10 minutes or less. 5 minutes.
Stretch the wrists as well. I'm thinking of something. You're gonna get me a break. I'll also tell Mike to make it big announcement. He always talk about the 3D.
It seems that it's a good time to also have a break washroom break, stretching legs break, coffee break, anything you want to call it. And we also have a quick announcement about this place. It's really interesting to know what this math lab does. It is interesting. The things that have been done here, that are being done here, are really, really fun. So you may want to know about them. Here is So here is Mike, the manager. The manager. Please.
Thank you, and thank you for all coming to Data Carpentry. I'm really happy to have this event here. It's really fun to host it. I just want to say that you're also, as UofT students, staff, or faculty, you're welcome to visit the Mad Lab, also to use our 3D printer service. So we have 2 3D printers there. You can come in and get trained on how to use them. We will train you if you've never used a 3D printer before. We'll show you how to turn any kind of 3D model into something that you can actually print out on the printers and how to operate the printer. So it's a really fun 1-hour workshop. We have one coming up on the 24th. It's not next Tuesday, but the following Tuesday. We also have a virtual reality lending service. So we have Virtual Reality Studio in this other room here. You've seen the computer there if you've been having a snack today. So that's also something you can come and use. There's no workshop or sign up or training you need for it. You can just sign up to use that. And we provide support for how to use it. And if you ever want to also talk about mobile apps, I'm a mobile app developer, and that's kind of what I do 80% of the time here. So please, if you ever have any questions about that, you can stop by, and I offer sort of consulting on mobile software projects as well for UofT. So thank you for the chance to welcome you.
Thank you.
Great. Thank you. Enjoy the rest of your session.
Yep. Go up, get up, stretch your legs.
And you can feel free to come and check out all the 3D printed items we have sitting here on display. So we have and then we have the link. So summer's a little bit less, but for design, you can really use anything like to generate CD data, as long as it's exported to imported into that software is free, so you can check that out. There's a 3D printing machine on the university software. The cost is $3 an hour. So that includes so really you just charge by time. So yeah, so you can print it's pretty much. There's another place called Maker Cafe. Yeah. The main guy was like 2-dimensional.
What about like a flower? It's like no, it's just a plasma user exchange like this.
PLA. Other pictures. We tried also. Traditionally, that's the material that's used to tool extruder and the material dissolvable material. Hold on. Water soluble. Use it in some other. It's like some of the most interesting things that people do here. Like atmosphere, like a cube or this happens. You can really knock it down. It comes in a roll like this. Yeah, I pulled biological materials. There is a machine that's online. You can find this forces the plastic. It like chops up the plastic and forces it to like work down and re-extract into that stuff again. So I guess people are starting to I guess like Play-Doh, you're smush back together. You use it. I don't know how many times you can do that. Yeah.